Hi, this is a build video for an Eggtimer Wi-Fi switch module, and you can use this to add Wi-Fi switching to any altimeter on the market, including some of the Eggtimer products that don't have a Wi-Fi switch. But this works for every single altimeter out there and allows you to switch them on and off without a physical switch. This is my setup. It's a Hakko FM203 with a silicon mat and some hand devices. I use a 0.3 millimeter iron and my own roll of Kester soldering wire. I also would tell you that I think this is one of the harder builds actually that Chris has, mainly because it's an older board and it has some smaller pads on it that don't quite fit the as well as some of the newer versions of boards he's created. You know, over time as he's revised other boards, he's increased the size of the pads or the length between the pins. So in this one, I would tell you it was a little bit difficult. I had to do it a couple times to get the video right, but I think once, hopefully you'll be able to follow along and do it yourself. So get all your parts out, take them out of the anti-static bag, and lay everything out on your workspace. I do like to cut out the Wi-Fi SSID passcode and put it to the side. And at the end, I write it directly on the chip on the Wi-Fi module once we've tested it and make sure everything works. But for now, so you don't lose it and you don't inadvertently throw it away, I would cut it out and put it to the side. And then we're going to inventory all the parts here. It is a little bit of a older design compared to some of the other ones that Chris has now, but we're doing the Rev A4b version from 2016. So we will grab the parts list and check everything off as we go. The first thing up is the PCB board itself that you're going to solder all the parts to. Then you have a Wi-Fi module. Pretty simple to identify with the big silver chip heat spreader on top. You got a voltage regulator, a 3.3 voltage regulator. Put that to the side. Next up, you've got a couple opto isolators. They're 8-pin chips marked A227. Now this is an odd one. It's MOSFET. You don't see this in any of the other builds that I've seen lately, so it's pretty identifiable. 3-pin. You get a couple LEDs. In my case, I got a clear and a red one. And now you're going to get a bunch of resistors. First up, you get a 1K resistor marked 102. You're going to need one of these. You get two. Chris gives you an extra one just in case you lose one. They're easy to lose. Next up is a 2.2K resistor marked 222. You get one of those, two of those. You need one. Then you will get some 4.7K resistors marked 472. You need one of those, and you get two. And then next up, you're going to get a whole bunch of 10K resistors marked 103. You're going to need 8 of these on the board, and then you get a whole line of them here. So if you do happen to lose one, you should be fine. In fact, you probably could lose a couple and you'll be fine. You get a lot of them, so you should be good there. And then finally, you get a 22K resistor marked 223. You need one of these, and you get two. So then we move on to the capacitors, and this is the 0.1 UF capacitors in a paper carrier. You're going to need one of these, and you get two of them. And in the old configuration of the board, you would get, and as it shows in the instructions, two 10 UF capacitors. But now, due to a voltage regulator change so that the board can work with 1S LiPos, Chris has changed those to a 1 UF, and that's the black stripe one, and a 4.7 UF, that's the green stripe one. And we'll talk about where those go in place of the other 10 UF ones on the board as we get to those in the build. But we have to be clear that those are different than the instructions would note. You get some through-hole resistors here that are going to be used for the Wi-Fi module. And then you get a 3-pin header, and you get some soldering wire. Now, I like I said, I use the same exact soldering wire on a spool, so I don't use the one that came in there. But if you don't have any of your own, this is excellent soldering wire. I recommend you use it. I do use a pan of ice. I do recommend using something like a pan of ice or some other vise. It's so much easier to use than taping the board to the work surface because you can move things around and your board's elevated. I use a pair of pointy tweezers and a pair of flat tweezers to move all the parts and components around on the board. And here we go. We're going to start with the opto isolators. Now this first opto isolator goes in place at the end of the board, and you have to line that dot up with the square notch on the silkscreen on the board. And the way you install these chips, you tin one of the pads, and then while you are applying heat to the pad, move the chip into place and line up all 8 pins on the metal pads on the board. Now this is where things on this board get a little tricky, and the reason I think this is one of the harder boards to build in the Eggtimer stable right now, because the pads on this board are exactly the same size as the pins. There's no extra, so you have to get it all lined up properly. A lot harder than some of the newer boards where Chris has expanded the size of the pads just a little bit, which makes it easier. Once you get it lined up though, go ahead and solder each pin to the pad. Now this is also another place where things can get a little tricky. It is extremely easy to bridge the between 2 pins on here, so be careful of that, and if go slow, and if it does bridge, no big deal. Just take your wick, your solder wick out, get the excess solder out from between 2 pins, and then go ahead and resolder everything cleanly. But if you do it right, then what you'll end up with is a nice little tent of solder in it, and it also gets underneath the pin onto that pad. A little bit difficult to tell here, like I said, because the pads are not bigger than the pins themselves. So make sure everything's lined up. Now we're going to deviate from the instructions a little bit here, because it says to do the opto isolator, the next opto isolator next in the instructions. I like to do this 10K resistor first, because it's in between the 2 chips, and it really makes it difficult if you put those in first. So I put this one in before I put the next opto isolator in. So tin one of the sides, get your resistor centered between the 2 pads, and then solder each side securely with a nice tent of solder, but not so much that it bridges underneath between the 2 pads. You want to get a little bit underneath the chip on the pad, and then a nice little tent on top. Nice and shiny, good solder. Now same thing for the other opto isolator. You tin one of the pads, line everything up. A little bit difficult, like I said. Take your time. If it doesn't work right the first time, come back, put your heat on, and realign the pad. It might take a couple times to get it lined up properly, but once you do, go ahead and solder everything. And we're going to speed up the video here because it's exactly like the first one. But all you do, once you've got all of those pins soldered in properly, we're going to move on to the voltage regulator. For the voltage regulator, just tin the large pad, and then move the voltage regulator into place, making sure that all the pins are centered, and then the small pins are centered on the small pads opposite. Once you have it centered and aligned the way you like it, take the heat off the large pad, and then you're going to solder the small pads in one at a time. Now when you solder the small pins in, make sure you wait 30 seconds between each solder. I am going to cut that part out of the video so you don't have to sit here and wait 30 seconds in between, but I did do that. I waited 30 seconds. So you should have a nice tent over the pin. You should have solder underneath the pin, bridging, connecting it to the pad, and then it should be nice and shiny like that. So once you finish the 3 small pins, waiting 30 seconds in between each, wait another 30 seconds to let the chip cool, and then go ahead and solder in the large pin with a pretty decent sized chunk of solder here. One, you want a good connection, but also that that chunk of solder does act as a heat sink for the voltage regulator. We have another resistor here. It's a 2.2K resistor right next to the voltage regulator. We're going to do this one in real time too, just so you can see one more of them. After this, we'll speed them up. But just tin one of the pads, center the component in between the 2 pads, and then one of the reasons I like the pan device, you can turn the board around very easily. So in my case, I'll turn the board and solder each end securely once again with just enough solder to get underneath the chip and connect it, and also a bridge, small bridge over the top. Now, here's where we have to talk about those capacitors we talked about earlier. And in order to accommodate 1S LiPos, you can see that the 10 UF capacitors in this note have been converted to a 1 UF with a black stripe and a 4.7 UF with a green stripe. And here's where they go. That black stripe one goes all the way at the end, and the green stripe one goes next to the voltage regulator. You have to make sure you get them right or this board won't work. So let's do them one at a time. This is the black stripe one, the 1 UF capacitor. This goes in just like the resistors do. It's in one of the pads. Move it into the component into place with the heat on. Let it cool, and then and here you can see if it doesn't line up properly, just put your heat back on and get it lined up. Then once it's lined up, go ahead and solder it securely on both sides. Same thing as the resistors. Now, once you have this one in, you can put the one with the green stripe into that other 10 UF spot next to the voltage regulator. This is the 4.7 UF capacitor. But other than that, it's put in the same way. It's in one pad, center your component, and then solder each side in securely. Now, once we've moved past this, we will continue working on these surface mounted components on the board. But from here on out, we will speed up the video for all of these. Now we're going to put all these 10K resistors on, and there's a whole bunch of them. There's 7 left. So like I said, we'll speed this up here so it won't go too slow. But put those 2 in on the other side of the opto isolators. Then there's 2 on the other side of the board right next to them. Get those 4 in. Turn your board around. Secure those in. And then we've got another few on this side of the board that need to be installed. And there we go. We get those in. And then there's 3 more right in a row. There we go. There's 1, 2, and 3. There we go. Once those are soldered in, we will move on to the next component. Okay, now this is a MOSFET, and you don't see this one too often. I have not seen this on any of the other boards that Chris has, so it's kind of a unique component right now. So tin the very large pad there, and then center the MOSFET on that large pad. Now the whole thing at the bottom is a plate that will be connected, so that's fine. It's those 2 small pins on the other side. You can see that they don't quite line up. It's hard to line them up on the small pads and get the whole large pad lined up properly. It might help if you try to center it without any soldering first, just to get an idea of where it's going to end up and be best centered. It's a slippery component with that big large pad on there, and also with that hole on one of the pads, it's a little difficult to kind of get everything lined up and stick. But once you do, I felt like that was close enough after trying to get it in. Go ahead and solder the 2 small pins. They are that one with the big hole is a little bit tough to get, so just make sure you've got enough solder under there to get a good connection between that pin and the pad underneath it. And then once you have the 2 small ones soldered in properly, go back and get a good solder connection on the large tab of the MOSFET. Now we've got a bunch more resistors, and we'll continue to speed up the video here. This is a 4.7K resistor. For the Wi-Fi module, I like to use the silicon mat. You're going to take the module and the through-hole resistors that come with the kit, and functionally you're going to put the resistor wires in the holes and solder them in as pins. So just lay it out, and then what I like to do is then tape the module right to the silicon mat that I use. And this is a silicon mat that's specifically designed for soldering. I'll put a link down in the description here. And the nice thing about using this mat is you can just put the wire right into the mat. It's kind of self-healing when you pull it back out, but it sticks there nicely and it holds it in place vertically while you're trying to solder it. So I stick the first pin in through the hole and into the mat, and then I do the opposite corner with another resistor wire and solder that one in. Now functionally your Wi-Fi module is stuck to the mat. It's not going to go anywhere. You could take the tape off if you wanted to. And then just use your clippers to trim the wires about halfway down from the resistor itself, because you're going to need to do this all the way around all of the holes. So from here on out, I'll do one more in kind of real time, but just go to each successive hole, push the wire through the hole into the mat, solder it in place, and then trim it. And then we'll speed up the video here because it's pretty much the same all the way around now. But each time you do this, you want to cut the wire off about halfway, give or take, up to the resistor itself. It's really, you've got plenty of wire here. At the end, when you go to actually put this on the board, you'll find that the long wires themselves, you've got plenty to deal with. So it's not imperative that you get it exactly halfway or the same. We'll even everything out and straighten out the wires afterwards. But for now, just go around and put each wire in each hole, solder them in. You don't need a lot of solder either. At this point, you're just basically tacking in the wire. Later on, we will solder up the top of the Wi-Fi module a little bit more to make sure you have a good connection. Right now, you're just trying to get the wire to stay in place vertically. And so as you get to the end here, you're going to get to the last couple wires in. Then you're going to take the tape off and pry the module out from the mat itself. And then I find that the easiest way to straighten everything out is to take just your flat tweezers and kind of align everything perpendicular to the module itself. So kind of do it lengthwise along the module, and then go back and look at each individual pin, and you'll see that it looks pretty ugly at the beginning, but within a minute or so you can align everything properly and have fairly straight pins. And then once you get them all aligned, relatively speaking, we'll make sure we'll kind of get them in place when we go to put them onto the board itself. But then take your clippers and then just even everything out. You don't have to, once again, it doesn't have to be perfect at this point. The main intent is to just make it easier to get it into the mounting holes on the board. Do be careful when you do this. I like to put my finger over the ends of the wires because it does have a tendency to spit out little chunks of wire there that can get all over the place or get in your eyes. So just be careful when you're trimming off the ends of these wires, and control the pieces that are flying off. And that's so that at this portion, that's it. Just once again, take a look at the wires. Make sure they're straight. Don't worry about the top right now because that's pretty irrelevant at this point. We'll trim all of those off later on. I like to put a little piece of tape underneath where the Wi-Fi module is going to go on the board. This provides a little insulation and also makes sure that nothing gets bridged underneath. But from here, you need to line up all of those pins now into the holes, and I find it easier to just put it on top and then kind of line each one up with your tweezers. And it should be pretty close now that you've straightened everything, but small little tweaks here and there get it properly aligned. And then this is how it should look when you get all the pins in the holes. I like to put a piece of cardstock underneath. It is almost exactly the 1/32 you need, because the module should not be touching the board. So then go ahead and just solder the pins underneath. Now you just want enough solder to get the pin securely in, but not so much that you're filling up that hole and possibly creating vias underneath between the board and the pins underneath. So be careful of that. But as you move forward, we'll speed up the video here because they're all pretty much the same. Just solder each pin in around the chip, and go back and touch them up if they didn't get a good solder joint on the first go around. But once you've got all the pins soldered in on the bottom, we're going to go back up and touch up the soldering points on the top of the chip, because these are these connections are very important, and if they're not right, even if one of them's off, your board won't work and it'll be hard to figure out why. So go back up and touch these up, but don't bridge any between the pads or dislodge your pins here. It can be easy to do. Once you've got everything soldered in properly, go ahead and trim all of the wires off. I like to use a pair of tweezers because these things do go flying, so be careful. Use some eye protection. Good thing about having a poor eyesight is you have glasses on anyway, as I do, but if you don't, I would use some, because these things can get dislodged. They can also go around and get underneath other components on the board and create vias. So do control that small pin that's being cut off and discard it properly. So once you've got everything trimmed down to the board, you're done with the Wi-Fi module, which is really one of the hardest components of this whole board. And we can move on. Now you've got another capacitor. It's another 0.1 UF right by the Wi-Fi module. So go ahead and solder that in. And then we have some more resistors, the last two resistors on the board, one marked 102 and one marked 223. Get those soldered in properly. And then we will be soldering in the LEDs. Now the long pin, and it's not very long compared to the other one, the long pin goes into the plus side, the positive side. So make sure you have the polarity right. But just drop your LED into the holes, and then just tape it down with a little piece of tape, and turn the board over and solder those two pins in. Once you have the pins soldered in, you're going to trim them off. Same method. Make sure use a pair of tweezers to control the piece that's being cut off. And for these are quite long, so I like to keep these pieces that you get from the LED. They make great bridge wires later on. So you might want to put that to the side if you're going to do these builds a lot. So then put the other LED in the power spot. Same thing, long wire goes to the positive side, drop it in the hole, tape it down, and solder that LED in place securely. Okay, once we finish this LED, we've gotten most of the components on the board done. It's actually not that many. There's a lot of resistors. That's increases the component count here, but really it's not that many pieces to this board. So once we've got that done and we've trimmed off your excess wires here, the next component up that we're going to be putting on is the 3-pin header that you use to program the board or be able to connect it to a computer. So that goes up there by the Wi-Fi module. So just put it in place, and then I like to tape it down by just putting the tape the pins right through the tape on these straight headers. That works great. And then just push the tape down. It makes it nice and secure. Solder those 3 pins in on the other side of the board securely, and then we will move on to the next component. Now my board didn't come with terminal blocks, but I had these available. So these 4-pin terminal blocks, make sure that the opening is facing out. If you face it towards the Wi-Fi module, it'll be very difficult to get the wires in. So put the 2 terminal blocks in, tape them down. If you're going to use terminal blocks, I like to use the terminal blocks on these Wi-Fi switches. It makes it a lot easier. But go ahead and tape them in, and then just solder in the 4 pins on the opposite side. Once the terminal blocks have been soldered in, we're going to have to test the board. to make sure it works. So the easiest way to test the board is to hook up a battery. I'm using a 2S LiPo. Hook up your connector to the in port on the battery side, and then just connect your battery. If your light blinks 3 times and then goes solid, you can be pretty confident your board is working and you soldered everything correctly. And then connect to Wi-Fi using the SSID, and you should get a screen like this. If you have a screen like this, you've done your job properly and everything's working. And that's it for this build. It can be a little difficult because of the small pads, but all in all, it's not too many components, so hopefully it works out for you. If you have any questions, post them below. Thanks and good luck.